Good morning, guys. Let's solve the problem on shear force and bending moment diagram. First of all, let's take the problem on the cantilever beam. Okay, so take down the question and write today's date. It's 26/10/20. Draw SFD. SFD means shear force diagram, and BMD. BMD means bending moment diagram for following cantilever beam. Okay, and the question is like this. Cantilever beam means one side support, other side free. 30 kilonewton A and B. Okay, so this is 3 meter. Now just we have to find out shear force at given points. So this A and B are 2 points on the beam which we know. Okay, so therefore I'll leave some space here so that I can draw shear force and bending moment diagram later. So now you can find out calculation of first one. Calculation of, so I'll take again little down. Calculation of shear force. What is shear force? Shear force at a point in a beam is the summation of all the forces including reaction either from the left hand side or from the right hand side. Now I will keep my hand here. I'll just see the left hand side of the point A. Shear point at any section, at section A. So at A, let's find out first. Shear force at A is equal to, if I keep my hand here, on the left hand side how many forces are there? Only one force is there, so it is coming downwards. So for left hand side, sign convention downwards is negative, so it's minus 30 kilonewton. Next, shear force at B. So if I keep my hand here, again there is none other force than this. It is summation of all the forces including reactions. So only one force is there, that too minus. So minus 30, and also you need to know, no issues, it is 30 kilonewton, or else so see here, since this is 30, the reaction here is also 30 kilonewton. So if I keep my hand here, so 1 and 2 are there, so minus 30, don't write down 30, minus 30 plus 30 plus 30 because it is moving upward, so it becomes 0. Please keep this in mind. Next is calculation of bending moment. So bending moment at A is equal to, so if I keep my hand here, for left hand side there is a force, but at point A there is no distance. Bending moment is equal to force into distance. So force is there but no distance is there, it's 0. So bending moment at A is 0. Now bending moment at B. So if I keep my hand here, so there are two forces, one this and other reaction. So both are there, but 30 is making, this is perpendicular distance of 3 meters. So 30 into 3, and it will rotate like this. So see here, if I keep my pen here and if I put the load here, it will rotate in an anti-clockwise direction. So for left hand side, anti-clockwise is negative. So 30 into 3 is negative, and this 30 is passing through the point itself, so no value. Minus 30 into 3, so that is minus 90 kilonewton meter. So now you can project these lines down and draw the reference line. So this is SFD diagram, this is BMD. So this is shear force at A is minus 30, upward is positive, downwards is negative, so minus 30, and here it is 0. So you would say it runs like this, but in one of the table I have said when it is a point load, the shear force will run straight. So this is minus, so since because 30 is only running, except 30 there are none other force, so it will run straight, and it is 0 at B. So hatch this, hatching is compulsory, and it's negative. Next, bending moment at A is 0, bending moment at B is minus 90. 90 is not upward, downward. So straight. So when shear force is straight, so see this is straight, bending moment is straight inclined. So this is also negative. Hence this way you need to solve the problem.